Hello everyone and welcome back to Introductory Programming in C. This is episode 2.2 where we're going to be going over constants and variables. So let's get right into it. Alright, so constants. Constants just represent unchanging values. So for example, the number of millimeters in a centimeter, that should never change. So we can define that as a constant by going #define and then the constant name, and then the constant value. So we want to do the number of millimeters in a centimeter. So we can do #define and then the constant name, let's call it millimeters underscore in underscore centimeters, and then the value, which is 10. Now you can see above that I've used all caps for our constant name. That's just a convention, but it's not strictly required. So all caps for constant name is convention, but it's not strictly required by the compiler. We can also set constants for any of the basic data types really. So integers, floats, characters, or strings. So we could do #define greeting and set that equal to hello. And that's totally valid as well. Now, why do we use constants? Well, they help us in our readability and assist us if we need to change these values in the future. So for example, for the millimeters in centimeters, if you were to use that in your program, that should never be changing. So why not just set it as a constant towards the top of the program, which is usually where you set constants, and it's going to reduce errors and just be a lot cleaner code. It also reduces the number of magic numbers you have. So instead of just putting 10 and people are like, why are you using 10? Better just to set millimeters in centimeters, set it as a constant, sorry. And it's much more readable and clear what you're trying to do, I guess. All right. Now, even if different constants have the same value, so even if different constants have the same value, it is useful to use different constant names. So useful to use different constant names. So for example, if we had something else that was also equal to 10, don't just sub in millimeters and centimeters, make a different constant. Okay? And finally, constants can be based on the value of other constants. Cool. All right, so now let's look at variables. So as opposed to constants, which are expected to never change, variables are expected to change. So they represent values that we expect to change. This is different from math variables, which are fixed. So if we have a little example, in math, if we have a equals a plus b, we could just subtract a from both sides, then b equals 0, and a can be any value. That's in the math sense of variables. However, in programming, it is a little different. So in programming, if we have a equals a plus b, this means take the value of a, add b to it, and then that summation, store the result back into a. So there is a difference between math variables and programming variables. Programming variables do change. Okay, so now what we just did above, a equals a plus b, that is considered an expression. And if you want to actually store a value into a variable, we use an assignment statement. So assignment statements used to store values in variables. So if we have a look at an example, we can have a equals a plus 1. That's an example of an assignment statement where we take the value of a, add 1 to it, and store that result back into a. It is important to note that with assignment statements, or with statements in general, they must end in a semicolon. So it should be like that. So I'll just note that down. Statements must end in a semicolon. The reason for that is so the C compiler knows where one statement ends and another one begins. It is possible to have all your statements on one line and just have no white space or appropriate variable names. However, I definitely wouldn't recommend that because debugging that is going to be nearly impossible a month from now or a year from now. And even if you write perfect code and it is correct, if it's in a business setting, you're probably going to need to change that code in the future. And if everything doesn't make sense or everything's on one line and it's not laid out nicely, then that's going to be super hard to do. So could have everything on one line with variable names that don't make sense. However, it hinders debugging and upgrading. All right, so now let's look at types. and types and declarations. So when you make a variable, it must be assigned a type. So variables must have types, okay? And they are assigned in a declaration. For example, if we do int number, what this means is that we're creating a variable called number, and we're setting that equal to the type int. Now, all an int is a whole number. So if we go all the way up to -1, to 0, to 1, and you keep going, any whole number. Obviously 1.5 isn't an int, or a half isn't an int, but any whole number can be stored in the variable number because we declared it as so. Now, declaring a variable does not assign it a value. So when we just do int number, if we were to use the number variable, that will contain an unknown value, okay? So what you can do is you can do a declaration and an assignment at the same time. So you could do int number equals 0. So let's just go over that. If not assigned, the value will be unknown. However, can do your declaration and assignment at the same time, as we did above. So then when we use number in the program, it's going to be equal to 0. If we wanted to change that variable in the future, we could just do number equals whatever value you want. Obviously, it's got to be an integer because we declared number to be so. So we could just make it 5, for example. All right, another thing we need to go over is integer maxes and overflows. So ints are typically limited to -2 to the power of 31 to 2 to the power of 31 minus 1. What this means is that ints have a limited value that they can actually hold, which is approximately 2 billion, which sounds large, but in the computing sense, it's really not that big. So we can have a look at an example, actually. If we go over here, we have this program where I've declared a variable called big, and its type is int, so it's going to contain whole numbers, and I've set it to just below the max, I believe. And we can print that out, and then what I've done over here is I'm printing out big times 2. And if you remember, that's going to go way over what the max of an int can actually hold. So let's see what happens. So if I open up our terminal, let's just clear all this for now. Let's compile it, gcc untitled-2-c, and let's run it like that. Okay, so you can see that our first print statement, you can see that we get the value that we set big to in the beginning, which is expected. But you can see over here, when we multiply 2 billion times 2, you'd expect 4 billion, but an int can't handle that much. So it actually loops around and overflows, and you get -2. What's important to note is that the compiler didn't throw any errors, and it's essentially letting you do this, so you need to be aware of this. So let's go back here. So what we just saw is integer overflow, and note the lack of warning messages. So it's important to be aware of types and the maximum value they can hold. All right, let's scroll down a bit. Now let's go over doubles. Now double types have a much larger range of values. You declare them with a double keyword and then the name, and then you can set it to whatever you want. Now doubles don't only hold whole numbers, they can hold decimals. So we could do double name equals 1.5. That's totally valid. Now the double is stored in 2 parts, an exponent and mantissa. I think that's how you say it. The exponent can have a very wide range of values. However, the mantissa is limited and can only represent accuracy to 14 to 15 places, which can cause interesting results. So let me just give you a quick example. If we go over to this program over here, I've made a variable called a, and it's of the double type, and I've set it equal to 0.1. Now over here, I'm going to print a, and I'm going to include a lot of places after the decimal, and I'm going to do the same over here, and let's just run it first and then go over it, I guess. So let me just clear this. All right, let's compile it. Untitled 3.c, and let's run it. All right, so let's have a look at the first print statement. So remember, we set a equal to 0.1. However, when we print it, you can see that we get 0.1 as expected. But if you go down the decimal places, you can see all the way at the end, we're getting these values over here, which you wouldn't really expect. We never had these values when we said, when we declared what a was to be. And you can also see that in the second print statement, where I have a, and I've added it to itself 10 times. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And obviously you'd expect 10 times 0.1 to be 1. However, when we print that out, you can see that we get 0.9 recurring, and then we get some other values over here. So this is really important to be aware of. I also just printed out the max of the double, and you can see that this is a really large number, and you have some decimal places over here. So doubles can hold a really large range of numbers, but it's important to realize the limitations in representing exact values. So if we go back over here, let me just scroll down over here. So you want to note the accuracy when using doubles. You can lose numbers when combining very large and very small numbers. There is another data type you can use. It's called float. Now the float, I'd rather say that doubles have double the precision of a float. So floats have reduced precision. And as a consequence of the reduced precision, let me just type this here, they also have a slightly reduced size. However, they're not, However, they're not often used really much. All right. Now, if we go back to constants for just a second, we discussed that constants have types as well. And if I give you a little example here, if we have 1e5, that's a valid value you can set your constant to. What that means is 1 times 10 to the power of 5. So that e5 just represents 10 to the power of 5, really. Now, when you set this as a constant type, if there's no decimal or exponent, then the type of the constant will be int. Otherwise, you're going to get the type of the constant being a double. So otherwise, double. Okay. You can also have character constants, as we discussed earlier, by using just the single quotes. And special characters can be escaped. For example, let's put that down here. So let me just explain this. If we wanted to do you can use the slash character, this backslash, to escape special characters. So if we wanted to print if we were printing this value over here, this will just print a single backslash. Or we can also do double quotes, backslash, single quote. That would be if you wanted to just print a single quote. So this backslash at the start allows you to print some special characters. Okay, and the result of this will be a char. That's the type of the constant, and you can use the %c format descriptor. Cool. All right, and finally, you must be careful. Be careful when doing division. So you need to pay attention to the types. And I'll give you an example. If you have 1 divided by 2, that will carry out integer division. Now what that means is because 2, let's assume here that 2 and 1 are defined as ints, then ints don't have a decimal place. So what will happen when you divide these is that it'll see how many times the denominator can go in the numerator, and that will be the result. So here, 1 divided by 2, that'll actually equal 0 when doing integer division. However, integer division. Wow, I can't spell division. Okay. However, if these numbers here were doubles, so for example 1.0 divided by 2.0, then you're not going to get integer division. You'll get the correct answer of 1.5. So that's something important to be aware of, because the compiler also won't alert you to this. All right, so good job getting to the end of the video. If you have any questions, please post them below. I've included a reference to Tutorials Point in the description below, which is a really good reference I use for information on C. In our next video, we're going to be going over operators and expressions, so stay tuned for that, and I'll see you there.